All right, guys, looks like we are live. I'm just going to go ahead and wait for the audio to come through and wait for a few more people to show up before we get started. But I am going to go ahead and play this for you so we can kind of talk about it as we're waiting here for people to show up. All right, so today we're going to be talking about an aerodynamic simulation. First of all, welcome back, everybody. No, I went quiet there for a couple days. I had a few things I was trying to plan, also trying to figure this out so I could show you guys kind of a new and improved version of our aerodynamic shader. So this is going to be combining a lot of different things here. Let me just go ahead and make sure my audio is good. All right, audio is good to go. We are good to go. Let me just blow up the chat here so I can see it. Okay, guys. All right, thank you guys so much for your patience. We're going to go ahead and get started here. So what we're going to do today is we're going to do another aerodynamic shader / geometry node simulation. This is going to be pretty fun. Overall, we're going to be using multiple concepts that we've learned in our past live streams. I know we've covered a lot of different things, but some of the main ones are going to include simulation nodes. We're also going to be messing around with gizmos as well. As you guys can see here, I have this awesome setup. We're going to be making it fully customizable, and I'll show you what I mean by that. As you can see, when I press pause here, I can actually adjust in real time these little kind of anchors here, and I can actually adjust the amount or where these grid lines are coming from. You can see right here, you can kind of see it a little bit better in this version. So now I can adjust the size of my simulation box. So if I want it to be tall and thin, I can do that just like that, and it'll update kind of dynamically as we're doing our simulation. Now you can see there's a few little glitches here and there, but overall this simulation is a lot better than the previous one. Let me explain why. In the previous example, right, we had our lines kind of going across, right, our flow lines going around our object, but in this case we didn't have them converging back together, and you can see right here they're starting to converge back together. So it took me a little bit to figure out how to do that, but then I finally figured it out. So again, before we had something that looked a little bit more like this, right? It would kind of hit our object, go around, and then just go straight, just like that. But now we have these lines converging in the middle, which is exactly what we want. All right, so let's go ahead and actually set this up in geometry nodes. I'll go over the basic node setup, and then we'll hop right into it. All right, here we go. All right, so over in geometry nodes, let's go ahead and click on our simulation. I'm going to zoom out. These are the nodes we're going to be covering today. I know it looks a little bit crazy. Let me go ahead and make my webcam a little bit smaller here. Hold on one second. There we go. I'm going to make my webcam just a little bit smaller. Perfect. All right, so we have a few different areas we're going to be talking about. I know this looks a little bit messy, but it'll all make sense in just a minute. Very first thing we're going to be doing is actually initializing our mesh. We're going to be instancing onto points, storing some values, simulating those values, and then converting everything to curves and adding our shader. The shader is going to be like the last thing we do. But you probably noticed some nodes that look familiar. If you guys remember our particle push simulation, these nodes right here correspond to those same nodes that we've used before. You can see that we have our named attribute, which is one of the pieces of data that we'll be collecting. And we also have the ability to actually move these points out of the way. So I'm going to talk about kind of what we did before and how this method is better. So let's go ahead and start completely from scratch. I'm going to pull the nodes up on my screen on the left here so we can copy them exactly node by node. Let's go ahead and open up a brand new document. I'm just going to save this. I'm going to call this, Control S. I'm just going to call this tutorial, and then I'll just call it airflow or something like that. Now remember, this isn't a true CFD or computational fluid dynamics simulation, but it's close enough. All right, I'm just going to go ahead and just add a cube. It doesn't really matter what you add. This is just going to act as our geometry node setup. Go ahead and go to geometry nodes, set a new geometry node system up here. Now we're going to start kind of like we start every other one. We're going to need a grid first. That's one of the first things we're going to need. So go ahead and add a grid. Unplug these outputs here. Now our grid is going to have to be fed into an instancer, so go ahead and feed that right into an instance on points. There we go, instance on points. Now a lot of people think that you first need to do mesh to points here. You actually don't have to do that because instancing on points can also just mean vertices, which I learned the other day, which is pretty cool. So you can do instance on points here, and then you're also going to want to transform your geometry as well. But first, let me plug this in and type in points for the actual instances themselves. So you can see we have our points, and this is our grid. If we adjust our grid, we get more or less points. We want to transform this though, right? Because we want our wind to come from one direction to go to the next direction. So we're going to go ahead and use a transform geometry node right here. And I just want to rotate this 90 degrees, right? So now we can send our points flying towards the right rather than up or down. And that's pretty simple. I'm just going to hide that because that one's really not that important. We'll come back to this later. Instances, I'm going to hide that as well, and I'm going to hide the points because all three of these things can kind of go in their same area. I'll just call this initialize geometry. Actually, I'll just call this initialize. Keep it super simple. Give it a quick save, and we're going to continue. So we're going to need to collect a couple of values here. We're going to need to use the stored named attribute to do that. So let me go ahead and explain what we're doing there. All right, so stored named attribute, we're going to need two of these. The first thing we're going to collect is a vector of our instance. So make sure you select instance since we're dealing with instances here. We're going to collect a vector, which is like an XYZ location. In this case, we need to collect the position because we need the position of our original points here. We need to know exactly where those were. And I'll just name this original position like that. You guys can name it whatever you want. It doesn't matter. Same exact thing over here, but this time we want an integer and we're going to select instance as well. And we're actually going to grab the index this time because the index is going to represent, just plug that in. The index is going to represent where each point is because what we're going to do is we're going to send these points to the right and we need to know where each one started because as they travel, I'll just show you guys this, as they travel, right? They're going to have their own individual streamlines. We want to make sure of that because if we don't do that, everything will be connected like this as one curve and it'll look super jumbled and we don't want any of that. All right, so let's go ahead and give that a quick save. All right, so right here, we're storing these attributes. We also need to name the second one. I'll just name it curve placement or something simple like that. It can really be whatever you want. Control J to join them and I'll just say store important data. Awesome. All right, the next thing we need to do is we actually need to simulate something. So I'm going to unplug this. We're going to add a simulation zone here. If I can spell it, simulation zone. There we go. And our simulation zone is going to accept this geometry and it's going to output the same geometry over here. Now, if we press play, nothing happens. And you guys know where I'm going next with this. A set position node is exactly what we want because that's going to allow us to actually, send our nodes kind of like into space here. So if I adjust any of these offsets right here, these values, I can make my nodes go one way or the other. So if I type in 0.1, for example, and I press play, you'll see that now everything's moving 0.1 in the X direction. Now in this case, we want it to move 0.1 in the Y direction. So I'll go back and press play. And I'm also going to add I'm going to do a vertical split here, if it'll let me, or a horizontal split. And I'm going to add my timeline down here at the bottom just so we can see, there we go, so we can see what's going on. I'm also going to adjust this to, 30 frames. Perfect. So when we play it back, we can see on a loop what's happening. All right, so like I said, every single frame, this right here is happening every single frame. So every frame, it's going to travel on the Y direction 0.1, which is great. But we actually want our points to be constantly generated over and over again. I know you guys have seen this before, but I promise you I'm going somewhere with this because we're going to be utilizing this in a different way this time. So in order to make this happen, we need a join geometry node right here, and we want to rejoin our geometry every single time. Now we're going to get something that looks a little bit like this, right? It's starting to look a little bit better because now we actually have lines from our individual points, right? And this is super powerful, and we'll get into everything else we're going to do later, but so far this is exactly where we're at. We have our points being generated over and over again. There is something really important I want to show you, and I didn't do this last time, so I want to make sure I make it apparent this time. If you click on this little drop down right here, you can actually click on timings right here, and I did not know this was a thing, but it actually tells you how long each node takes to calculate. It sometimes does not work for every node. I'm not sure why, but you can see right here this little timing right here, 0.1 milliseconds. I love that it does this, so you can actually start to see as we build out our node network what takes long and what doesn't. So this is pretty crucial. All right, so let's go ahead to the next step here. All right, so we have stored our important values. We have our instancer. Now we're going to go ahead and set up our curve line, and then we'll actually we're not going to set up our curve line yet. We are going to utilize the particle push code that we had from before, and I'll explain how we're going to utilize those attributes that we've created. All right. I'll also place this here because this doesn't really matter yet. All right, down below, this is going to allow us to move our points back if they're not being touched by an object. But we do need an object, so let's add a UV sphere in here. Let's scale it down, move it right about here so the particles will start to intersect. You can see nothing's happening right now. We're about to like program what happens if that object is touched. Let me go ahead and get a quick drink of coffee here. All right, very first thing we need to do is we need to reference this named attribute. If you guys remember, we have the original position. So we're going to reference that named attribute. We're going to, of course, look for original position. There it is right there, which is a vector. We're going to subtract that. We're going to use vector math. We're going to subtract it, not add it, from the position. And remember, the position is, it's constantly reading where these points are. So it's kind of like taking that difference. We're then going to use another vector math node, but this time we're going to scale it by a certain value. And that value is basically going to be our speed, more or less. We can use any value you want. Oopsies. You can use any value you want. In this case, I'm using 0.01, which will make sense in a moment. Awesome. All right, and then the next thing we're going to need is another vector math, but this time we're going to add, and we're going to add our position back. Boom. Just like that. So we should have something that looks kind of like this. I'm going to highlight these, put them into a group, make sure they're formed exactly like this or it will not work. All right, and I'm just going to call this snap back to original position because that's what this code does. I did borrow this code from another project, so I'm not going to claim that I originally created this, but it does work. Next thing we're going to need is a switch node, and that's going to check our connection. So the switch node will decide between two inputs. It'll either be true or false. And in this case, we're going to actually use a vector instead of anything else because with the vector, we're comparing X, Y, and Z and like where things are rather than like one thing or the other, if that makes sense. So we're going to go ahead and plug this into the false, right? Because this will make sense in a second because this switch part right here is going to tell us whether or not to switch between one or the other. So if one thing happens, snap back to the original position. If not, we're going to program what else could happen. But this output is going to be fed into the offset, okay? Or I'm sorry, the position. Let me just make sure I have that right. Yep, it's going to be fed into the position. And I'm going to go over this in a second, but we can also separate our XYZ right here and then recombine it. You're probably thinking, well, why would I want to do that? If you want to, this is up to you. You can decide if you just want X and Y to be affected. And if you want to, you can leave Z out. I'm going to leave this in just because I want you guys to have that option. And I'm also going to join these together. And then I'll just call this, oopsies. I'll just call this, I don't know, XYZ filter. Something like that. Just so you guys know what it does. Oops, I labeled the wrong thing. XYZ filter. Awesome. And then this switch will decide the condition that we're in. So let me also join this. You can also just rename the node, but I'm going to say condition check. Awesome. So we're checking the condition between this and one more thing. Okay, save that. You guys probably already know what this is going to do because you remember the particle push, but this part's really crucial right here. This is kind of the part that's actually going to check everything. So if you remember before, we have our sphere. This is the thing being affected. I'm going to drag my sphere down into my nodes. And now I have my object info, and we can customize this later. We're just going to use the sphere for this example. All right, so I'll add some other nodes in a second, but the very first thing we're going to do is sample the nearest surface. Do not do sample nearest. Make sure you do sample nearest surface because we're looking at the surface of the sphere. I'm going to go ahead and plug in my geometry right here. Make sure it's set to relative, not original, because if you take this and scale it, it will not work unless it's set to relative. If it's set to original, it'll look at the original place the sphere was and the original size of that sphere. All right, we're going to take another one of these, and we are going to plug in our geometry again to this. This part's going to look a little complex, but it does work, and it works very well. All right, we're going to need to sample the normal, and we're going to sample the normal as our value for this sample nearest position. And then for this one right here on the top, make sure that's set to vector, and this one's also going to be set to vector as well because we're dealing with XYZ values. We are going to subtract the output of this, so vector math. We're going to subtract the position. All right. And then we're also going to use this position as the original value right here. So the position is going to feed into both of these. The normal is going to be checked here. And then we're going to take both of these outputs. I'll just duplicate this vector math. We're going to switch this to dot product. And we're going to take these outputs and get the dot product of both of those. And then, this is where it gets fun. Whatever that result is what will check our switch. So now the switch is going to say which one of these is true, this one or the bottom one. If one of them is true, sample the nearest value right here. Just want to make sure this is working, and it is not yet, and that is because why? Am I missing a node? Sample nearest vector, got it. Vector math, yep. Normal, position, subtract, value, yep, normal. All right, hold on, I must be missing one thing. And I targeted it as a relative object, good. Plug that into the bottom. And why isn't it working? Oh, I think I know why. Hold on. Let me push this. There we go. Okay, it is working. All right, the reason you couldn't tell it's working, this is going to be kind of hard to explain because there was so much experimentation that went into this. You probably see this little line. Hopefully you guys can see that. You see this little line. Let me hide this so you can see it. This is what's happening. So our points are moving out of the way, right? Well, just this one is, and it's moving around the sphere. The reason it's so hard to see what's going on, there's a couple things because I had a fix for this that works really well. We're actually going to scale this object up. I'm going to use scale elements, and we're going to feed that output back into where we had the meshes before. And we're actually going to scale this up by 1.2. And now you'll see, so everybody see what's happening now? Now our points are moving around our object because it's almost as if we've created a barrier around the object that then pushes these points out just a little bit more. And to really show you what's happening, let's raise the resolution of this. Let's do 5 points so you can really see. There you go. And I'm also going to make these points have a smaller radius. Oops, let's do 0.01. There we go. All right, does everybody see what's happening now? Now we have all of our points traveling around our object and basically more or less avoiding the object. It'll sample the surface and then reset the position of that point to the surface. Once it gets past a certain point though, it'll bring it back to the original position. So if we press play and we look at this here, you'll see that all these points are going to converge. Notice how they're starting to converge. I'll up this to 60 frames so we can see. All right, perfect. So you can kind of see how they're starting to reconverge here, right? So they're moving around our object and then they're reconverging right here. All right, and the reason they're doing that, if I can zoom out here, is because we're moving them by 0.1 on the y-axis every single time, and then we're checking the condition to see where they're at, and if they're at a certain location, they will reconverge. All right? Hopefully that all makes sense. And remember, right now, all we're using is this original position. I told you we're storing important data. This block right here, this curve placement, now we're going to use that to rejoin everything back into a curve. Let me just see if I have any questions. I don't yet. That's okay. All right, now this is the fun part because now we can start to make this thing actually look good. All right, so we have our collision checker, all this stuff down here. I think, let me just see what I named it in the last project. Yep, check if the points are near the object. Yep, that's fine. All right, so right here, I'm just going to join all these together and move these out. And I'm just going to call this point checker or something like that. Check if points are near object. Perfect. Okay. You can color code this. We can come back and clean up these nodes later. But let's go ahead and convert these points to actual curves. All right, so there's a couple ways you can do this. I'm going to do it the way that I did it in the old project because I feel like it works best. I'm going to do instances to points, not instance on points, but take my instances, convert them back to points, even though they're kind of already points. This will work either way. And then I'm going to do points to curves. And now you can see, remember the problem I said we were going to have earlier? All of this is working, right? It did convert our points to curves like we asked it to, but it's connecting every single point into one big curve. That we don't want. So how do we fix that? Well, this is where our curve group ID comes in. You guys remember that stored named attribute that we had before? I'm just going to go ahead and type in stored named attribute, or I'm sorry, named attribute. And we're going to go ahead and search for our curve placement. We're going to plug it in right here. Now look what we have. Now all of our curves, if you guys can see that, are all 1. Now they're a little jaggedy and we're going to fix that. But how awesome is that, guys? We now have curves for every individual point that was generated. And now you can start to see how this project's coming into play, right? And they're reconverging, which is the huge thing that we solved last time. We did not do that. This is 10 times better. All right, let's go ahead and resample the curve because we want it to have more or less points. You can already see it's starting to look smoother, right? It's a little bit weird and organic and kind of looks like some sort of creature right now, but it is working, which is fantastic. We can come back to this resample later. I have it set to 11 in my other project, so I'm just going to set it up like that. We then need to set the spline type. Now the spline type is either going to be poly or Bezier. I'm just going to set it to Bezier because that's the more curvy one. And then we're going to go ahead and set the handle type, which is basically also the same thing. Look at how smooth it is now, right? You can kind of see the difference here. You do want your resampling to be high enough that you still have detail, but if it's too low, let me just show you what happens if it's too low. If it's too low, you don't really get that same effect, right? Things still wrap around, but they're not quite the same. This is like a higher value. If you set it to like 15, then you see how it starts to kind of get really weird towards the end. So I'm just going to stick to 11. Next thing we're going to do is we need this to be a mesh. So we're going to do curve to mesh. Now our curve to mesh, we need a profile for the curve. So I'll just set this to a circle. I'll do a mesh circle. I'll go ahead and plug that in. Or I'm sorry, curve circle. There we go. Needs to be a curve circle. It will not work if it's a mesh circle. I'm going to set the resolution to 10. Radius, I'm going to lower that a little bit. And we should have something that looks kind of like this. Awesome. This is actually pretty much exactly the whole tutorial right there. But there's more because we're going to start to deal with the colors and other things like that. All right, so the next thing we're going to do is I'm going to show you guys how to choose between two materials. We're also going to mess around with the timing a little bit. The two most important values, I just want to outline them real quick after I group this stuff. I'll group this, I'll just say convert to curve, and then I'll just really quickly set up our material. This right here, this section will be choose material. We'll come back to that. You can kind of see this timing thing is cool, but it does get in the way. And I like to look through these and see which one takes up the most. Like this one is pretty heavy in terms of like the amount of milliseconds it takes up. It may not seem like a lot, but that adds up pretty quick when you have a lot of nodes. The join geometry one, I'm not sure why it's not showing up, but that one takes up a lot of time and it's not doing it here. My last project, it took up like at least 59 milliseconds. All right, so what we want to do is now that we have everything all set up, we want to go ahead and mess around with two values. This value right here, which is the set position, which is how fast the particles are moving. And then this right here, which is our value for our scale. This is kind of also sort of how fast it's moving, but it's also not. But they kind of work hand in hand. So I'm going to set up the custom values I had from before. I had 0.01, and then for my speed, I had 0.06. For some reason, that worked really nicely. So let's see if it works really nicely here too. Yeah, that looks really good. Now, you can see we still get the convergence, right? You can kind of see they're slowly converging. If you want this effect to be greater, you're going to have to mess with these values. I kind of like the values that I have. I find that as you experiment with them, you can get different results, right? You can see like right here, we're not quite getting too far. So let's extend our frames to 120. So look how that's basically like slow motion. Let me try something a little faster. There we go. If that's the result you're looking for, go for it. It's totally up to you guys. And then last but not least, our boundary is going to be down here. This scale elements after our sphere. Remember, this is our boundary, 1.2. If I raise this up to like 1.5, look at the difference here. You can kind of see that there's a barrier, right? It's not really hitting the sphere. So you're going to have to adjust that value depending on your shape. But so far, guys, this is looking really good. Just to test if it's working, we'll go ahead and duplicate our object here. And scale that up a little bit. And let's see if the curves go underneath of the second object. They do not. Why do they not? Let me double check something here. It might be this value right here. Let's try to lower that and see if this works. Sometimes the slower the speed, the better it will work. But also let me check if my resampling is not high enough. Nope, sampling's high enough. Good. instance on points. Again, you got to mess with these numbers. Let's try that. It is actually working better, but then we get these really, really weird squiggly lines, so you may go for a different value. Let's try that. That's a little bit better. We're getting there. I'm pretty happy with what we have so far. Again, it takes some experimentation. Sometimes if you set both values to the exact same, you're kind of good to go. That's better. That's much better. Set that to 0.5. And the other one, we'll set it back to 0.2, I believe. That might be it right there. It's a little bit slow, and some of these points are going inside the object. But with some experimentation, we can get something good. Oh, also, our scale is super high for our object. Awesome. Okay, this is looking really good. All right, is everybody following along so far? We're going to continue with our shader setup now. Or should we do the gizmo first? We'll come back to the gizmo. Let me think. We'll do the shader setup first. The shader setup is a little bit annoying, but it is possible to do. We're going to be using geometry proximity and curve tangent. Or no, we're going to use geometry proximity, map range, and a stored named attribute, just like before. All right, so let's go ahead and go over to our material. Let's set up a new material. So I'll go ahead and click on new material. I'll call this colored because we want, actually I'll just call it, how about speed? Because it's kind of showing the speed and the pressure. I'll go ahead and use that here. We'll go to our material preview. You won't see anything yet. Let's just go ahead and make sure everything's linked up properly. In order to make sure this is linked up properly, just change your color to like an off color like that. That looks good. We're gonna use a hue and saturation node, or I'm sorry, we're gonna use a color ramp. We're going to plug our color ramp into the base color, and then we're going to use an attribute node. This node, we're going to link this in geometry nodes, so go ahead and plug in the FAC to our FAC, and you're probably going to see, wait a second, why did everything turn black, Kenny? This isn't working, you lied to me. No, I did not lie. We need to name this first. Let's name it, how about ramp? Just call it ramp. Doesn't really matter what you call it. And then we need to use something called a stored name attribute. And in this case, we're using a float. Point is fine, and then we just need to type in ramp. Okay, and then we're gonna be able to change the value right here, but we're gonna change this based on a float curve, or sorry, based on a map range. So we first need to get a geometry proximity node, and we need to figure out the proximity of our sphere to our curve lines. So in order to get that, I am going to go all the way over here where our object info node is. I'm gonna drag our geometry output, and we'll see if we can find and fish for this other node. There it is. So there's our geometry proximity. Was there an easier way to do that? Probably, but I kind of like the challenge, you know? All right, so we have our geometry proximity, and we're gonna plug in the distance, which is the distance from the lines to the sphere, into a map range node. And then we're gonna plug our map range into our float point, into the value. There we go. All right, now in order to see if this is working, let's crunch these numbers a little bit, and there it is. So here's what's really cool about this. Basically, with this object, like let's just say we scale this down, move it, you can see that it kind of follows where the object is, right? So it's mapping the proximity of the sphere to wherever the lines are. Now, is this physically accurate? No, not necessarily, but now we can like customize this very quickly. Sometimes I'm all for the speed over like the accuracy of the simulation. Sometimes. In this case, I'm fine with this because I know I want red to be like those stronger areas where the wind is like catching. And then for the other areas, we can just make those like green. And then we can go into maybe like yellow. I want to say yellow. Is that working? And then maybe blue. Let's just see. Let's see if blue shows up. Yeah. Wait. Why does this look so weird? Oh, you know what? I'm going to do HSV. And we'll do far. No, we'll do, oh my God, near. That's fine. Perfect. Something like that, maybe. Except for I'm not really looking to get, you know what? I'm switching back. I changed my mind. This is fine. Perfect. Perfect. I don't know. That looks decent. I don't know why we're getting such like weird coloring though right now. All right, that looks better. For some reason, maybe the yellow wasn't needed. I don't know, but this looks really good. So when we look at this, right, we have our object, and we move it, and we can see the like quote unquote heat map. Remember, it's still gonna work, but you have to wait for it to update. So as you play it back, just make sure you guys like be patient. Because like, look, see, I moved it, now it's not working. You have to wait for it to play back around, or you reset your timeline to like 1. Okay, so we have our really awesome material. Let me just double check what else we're gonna do here. All right, next thing we're gonna do is we're gonna develop a material for smoke. So you're probably thinking, well, I want this to look like a smoke simulation. Kenny, you lied. I didn't lie. We're gonna set it up now. Let's go ahead and make a new material slot, make a new material. We're gonna do principled volume. Now, here's something I noticed. This is a little glitch I noticed in Blender. Maybe not a glitch, but maybe it's my glitch. Maybe I am the glitch. But in our new material, for some reason, the default for the principled volume is plugged into the surface. We want it plugged into the volume. Boom. I don't know why. Maybe it's just when you change it, but this is going to be really cool because now we're going to be able to make this look like a volume material as well, and we can make it look like smoke. All right, so all this, we'll still keep all this, but we're actually going to use a switch. What do you call it? Menu switch for this. So for the material, let me just move all this stuff over here. We're going to use something called a menu switch. Now, a menu switch, I'm going to just explain how it works because, actually, I guess I can just show you how it works. When you have a material that you want to set, like for example, set material, our output for this, we can change this to material. We can choose from a variety of materials. So like if we have 2 materials, for example, this one's called smoke, the other one's called speed, I can add a material. Make sure you don't do set material, just do regular material. I want my smoke to be the first option, and then I want my speed to be the second option. So now we have 2 options here, right? And then we can decide which one we want to choose. How do we decide that? Well, we can let the user decide. We can add a group input node, and we can plug that into the options right here. And now on the right, in our modifiers tab, I can switch between the 2, right? But we have to get rid of this because we don't need that anymore. We still need our stored named attribute because we want that to apply to whatever shader we choose. But now you can see I can switch between the 2 of them. The reason you can't see this smoke is because we don't have any light. So let's add a light. Now you can see the smoke a little bit. I'll increase the light intensity. Now you can see the smoke. Pretty cool, huh? And then if you want this to be more dense, you can just go back to the shading tab and you can adjust your density right here. You can raise it to 10, whatever you want. Does it necessarily look like smoke? No, not really. So if you really wanted to, you could add like a noise texture, color ramp node, and then maybe just like, I don't know, plug it into the density perhaps. Let me just try something here. Let's try this. Did that work? Oh, there we go. So yeah, if you want it to look like a little bit more like smoke, like a little bit more broken up, you can do maybe something like that. Maybe set this to 4D. There we go. Again, you don't have to do this, but this is just like another option for like a shader that you can create. In terms of like actual smoke simulation, if you want it to look really like smoke, just do a smoke simulation. This is really more for like a stylized look. He said, bro is cooking spaghetti again. I know. I do think this looks really good. Let me just double check and see what else we're gonna do. Okay, so we're gonna adjust this via gizmos now. So this is gonna be the fun part. I like adding, this is more customization. I just learned about gizmos today, and I'm gonna teach you guys what I learned. Also, quick shout out to Default Cube, because he's the one who showed me how to, I just hide this. He's the one who showed me how to use gizmos. But real quick, before we do that, let me just join this stuff together. Okay. We want to keep our nodes as organized as possible. If you guys have ever coded something before, you know that you always comment on your code so that when someone else goes back to it, they know what the code does. Or it's just like a helpful comment that will help them understand the process that you went through or how something functions. So I'm going to call this choose material. All right, we are good to go. Also, this right here is for our custom color ramp. Perfect. Save that. Always saving. Always saving. All right, let's set up our gizmos. So far, this is the geometry node setup we have. Let's go ahead and set up our gizmos over here. So right now, if we want to change the size of this thing, right, all we have to do is we adjust the size of it right here. So you can see I adjust the size, and now our grid's going to be larger or smaller, right? Pretty simple. But if we want to, we can actually use a gizmo to adjust this. This was a little harder than I thought it was going to be. It was kind of a pain, actually, but thanks to Default Cube, I now know how to do this pretty easily. So we're going to use a gizmo. We're going to type in gizmo. I'll use a linear gizmo for this one, and you'll see right away that we kind of have something that kind of pops up. We're going to use this for the x-axis, and we're just going to use a box for this so that we can click and drag. See this little box? We're going to click and drag that box. So what do we want to transform? We want to transform the x. So I'm going to first make sure that we can control it from the modifiers tab. Once I know we can control it from the modifiers tab, I can then plug in that value to the gizmo. And you'll kind of get this double line feature here. That lets you know that it's working properly. And then once you have that, all you have to do is adjust it. Oopsies. Oh, we also want to make sure it's facing the correct way, which it's currently not. We want it to be facing the x direction. So we'll do 1 for the x, 0 for the y. There we go. And now if I click and drag it, you can see that I can adjust these things. But you also notice how this snaps back to the middle. I'm going to use the same technique that Default Cube used to actually make this not snap back to the middle. And what he did is he actually took this output and he did separate XYZ, and then he did combine XYZ. He just combined the X, set that to the position. All right, and there it is right there, right? And you can see that it's adjusting, but you can see how it's a little bit far out, right? It's on the end right here, which is great, but it's too far. So we need to actually divide that by 2. In order to do that, we're going to do a vector math right here, and we are going to, or I'm sorry, we're going to do a regular math in the middle. We're just going to divide it by 2. Boom. So now when you adjust this, it stays on the end where it should be. And then if we press play and pause, we can adjust this back to normal. Now, another thing that I noticed, though, in his tutorial, we can actually make this even better. We can show the bounding box of where this thing is. But first, let me duplicate this for the other gizmo. Also, let me remove this from the frame. I do not want that in the frame. All right, there we go. Okay, so I'm going to go ahead and just move all this down here. Linear gizmo, that's fine. I'm going to duplicate this, bring it up. I'm going to change this to Y. Well, in this case, it's actually, technically it's Z, but since we flipped the grid, it's now Y. This will make sense in a second. Plug in the Y, plug this into the Y, boom. And we will go ahead and make sure that we have the grid's Y to work with. We're going to plug that into the value for the linear gizmo. And we're going to go ahead and make this Z. There it is right there. And then do we have it divided by 2? We do. We also need the vector of the Y. And let's see if that worked. Did it work? No, it did not. Y. Oh, because this is actually, is it actually Z? No, it's actually, oh my God, hold it. If I flipped it, hold on. Y. Nope, hold on. You can do this. Is it actually Z? It is actually Z. There it is. Okay, it is actually Z. I'm sorry. The reason this was so confusing for me, I swear I'm not stupid, is because when we took our grid, we originally transformed it right here. And so I had to rethink how we transformed it. So now we're dividing that value by 2. We're actually dividing Z, and then we're plugging it back into the Z, and then the position of the gizmo will update based on the size. So if I want to crunch this down to like a small cube like that, I can keep crunching it down and crunching it down. Now I have this smaller cube. But wait, we can't really see where that cube is. And that really frustrated me. So what I did was I took this object after transform geometry. I made it into a bounding box, and a bounding box just contains the size of whatever you're working with. And then I plugged it in at the end into a join geometry node. We got to drag this all the way from the start, all the way over here. And now there's our bounding box, right? But you're probably thinking, well, I don't want it to be a plane. Now what's cool is you can now adjust this plane and see where the lines are going to appear from. But instead of having this be, let me just add a reroute node. Reroute, there we go. Instead of having this be just a bounding box, reroute. me just, here we go. We can have this be a curve. So let's do mesh to curve. And now you can kind of see the bounding box, right? And if you really want to, you can add a curve profile, but I don't think we need to do that because now we can adjust this with our gizmo very easily. We can also do the same thing with a radius and the, with a dial gizmo and the density. But right now, I'm pretty happy with like how this looks. Yeah, I'm super happy with how this came out. I love the gizmo thing. I'm going to have to use this more often. Like this is super useful for future projects. In my case, I think I'm going for something kind of like thin and like taller. So let's see what that looks like. Yep, that looks really good. And let's play this out to 120. Look at that. Let's see if the coloring still works. It looks good. We have our gizmo working, right? If we want to, we can make the lines bigger. And that's really the tutorial right there. That looks so good, guys. What does everybody think so far? This is, I mean, this one came out great. This looks fantastic. Wow. All right, so what I wanted to quickly do, we'll come back to this. A couple of things I wanted to quickly do. I want to go through, I actually have an agenda for this live stream. All right, we went over the demo. We went over that. Awesome. I want to quickly shout out this course that I'm a part of and also many other amazing Blender users are a part of. They're all Blender enthusiasts. They all have their own skill set. This is the core fundamentals of Blender. This is not an advertisement, but rather an opportunity for you guys to learn so much more about physics, specifically with my course, but also so many other things. Let me just show you guys some of the stuff you can learn because I took all these courses and I feel like I know so much more having taken them. Mesh modeling, you can never know enough about mesh modeling. I don't care what you say, no matter how good you think you are, you can always learn more. And really in any subject, not just mesh modeling. But I've seen people do stuff in mesh modeling that I have never, ever seen before. We have digital sculpting with Kent. I know Kent personally. He's a very good instructor. You're going to get the highest level. I mean, really, with all these, you'll get the highest level of quality. But I promise you, if you do take the cgcookie core courses, any of them, you can buy them individual or you can buy the whole thing. It's definitely worth signing up for. You guys probably know Kaizen. He's doing the fundamentals of lighting. Again, just a core concept for artwork and 3D work. This is by far one of the best that you're going to get right here. And then we have Iwa. She has materials and shading. She covers that. Don't worry, we're getting up to my part in a second here. Texturing, again, with Iwa. She's kind of a master at this stuff. You should see some of the stuff that she creates. She's just super awesome with the procedural texturing. And then we have animation with Phil. Again, like a staple of the core fundamentals. Like, it's animation. That's what Blender's made for, right? Rigging, again, Blender's awesome for that as well. And we have Wayne Dixon, who's a renowned artist and professional rigger. And then we have yours truly, Kenny Phases, with physics. And yeah, so I go into not geometry nodes, but I go into like standard physics. I just want to show you guys real quick. Well, I'll go back over the last one here. We have compositing with Sean. This is such an overlooked area. I would definitely consider checking that out. And then I want to show you guys my course real quick. Yeah, so I cover the fundamentals of physics in Blender. We have a few great reviews on here, but I do want to show you guys some of the stuff that you'll be learning about. Right here you can see we have some spring physics. This is really fun. This is a fun little project that we work on. We have some jelly icospheres that we've created here with soft body physics. We talk all about cloth physics. Man, is there some fun stuff that you can do with that. We have fluid, smoke, and fire, particle systems, dynamic paint. This is probably one of my favorite. Dynamic paint is a really fun one. Force fields, you can't go wrong there. And then, of course, some troubleshooting. And yeah, so I kind of walk you through all of the fun stuff. Let me just show you guys the course trailer real quick, and then we'll hop back into Blender, okay? All right. Oh, no sound. Hold on. Have you ever wondered how to bring your digital creations to life with realistic movements and interactions? Introducing the fundamentals of physics in Blender 3D. Imagine creating animations where objects move, collide, and react just like they do in the real world. From gravity and collisions to fluid simulations and even soft body dynamics, I cover it all. Whether you're a complete beginner or looking to enhance your 3D skills, this course is packed with hands-on tutorials and practice tips. You'll you'll learn how to create stunning, realistic animations that will wow your audience. By the end of this course, you'll have the confidence and skill set to simulate realistic physics in your own 3D projects. Subscribe now to CG Cookie to stream the fundamentals of physics. Awesome. All right, so yeah, I just wanted to shout this course out real quick. It is obviously available on CG Cookie. It's also available on Superhive, and there might be one more location it's available. But those are the important ones. Let me just go ahead and copy and paste the link in the chat real quick for you guys. Just go ahead and paste that in. Is it really not going to let me paste that in? Yo. I'll just paste it over here. It's fine. All right, I do want you guys to at least check that out. Check out some of the, go ahead and check out some of the trailers. All right, awesome. Thank you guys so much for listening to that. My computer is like frozen. What's going on here? Okay. No idea what my computer thinks it's doing right now. Okay. There's a slight chance my computer is about to like crash. Control Shift Escape. Oh, of course that. Oh, okay. All right. When all else fails, Control Shift Escape. Okay. We are back where we started. Awesome. All right. So for those of you who are still sticking around, we'll try to kind of wrap this up soon. But I think overall, there's so much to learn from those courses. Again, I kind of can't express enough how useful they really are. I found myself like going back to one specifically. I think it was in the mesh modeling. There's just so many powerful techniques that you can use. All right, so here is what we have so far, guys. I'm super happy with this. One of the cool things we can do now is we can like experiment with different objects. I do realize this is running a little bit slow, so if you want it to run faster, you can go over here to our FPS and you can like bump this up to 60. All right, totally up to you guys. You don't have to do that. I find that the slower the curves move, the more accurate they become for some reason. So let's mess around with a few values real quick. Let's go back to our speed. Let's try like 0.02. You do get some weird results though, and I'm not sure what that is. Of course, it works fine now. Okay. I do think these two work in conjunction in a very strange way. Again, you do get that convergence. That convergence was really the huge thing here that made me really, really happy about that. All right, I just turned this down to a really low value. Okay, so the higher the value is, I guess the more they convert. Oh. Okay. Okay, hold on. Oh my God. What is happening? Oh. Oh, this was that issue I ran into before. So this is a cool one. If you got, I'm a little stumped on this one, but if you guys want to check this out, for some reason, certain values will make the curves just stop and like at a certain location. And I just, to be honest with you, don't know why. I'm not sure why. But yeah, that's something I've been trying to solve. Let's try 0.07, see how that looks. So weird. It's getting these like, I kind of understand like what's happening because it's trying to resample. The reason it works sometimes is because we're not giving it a chance to like, we're not giving it a chance to resample. We're just saying, nope, please move past that, right? Like we're almost past that point right here. Now we are past that point, right? So it like can't really resample because it's not close enough to the surface anymore. So strange. Okay. This is a fun one. Let's take a look at the nodes and see if there's anything else we can like customize. We have the ability to choose the material. If we wanted to have the ability to choose the object, we could just add our group input right here. And we could just go like that. And boom. Now you can choose the object. You can adjust the size. We also have, of course, these gizmos to adjust the size as well. And they should update after it plays back. Perfect. And then we have options A and B. I do want to show you guys with the group input. Where is it? With the menu switch, if you go up here to the group input, all you have to do to change the menu switch options is you go to the node option, and right here you can double click and you can just say smoke, and then you can choose speed. That way you have the specific thing for what you need. And you actually, oh, where's our area light? And then you'll actually be able to like see what's going on, right? You can swap these out. Now maybe that area light's too intense. You can also adjust that as well. Shade that smooth. Looks fantastic though. I'm particularly pretty happy with like the result. Let's see. I do think that this area light though should be like centered kind of. That looks cool. What do you guys think overall? Oh, there is one more thing we can customize. My fault. We can customize the radius right here. So if we want to, we'll add the group input here. And we can customize the radius of the like curves. Like if you want them to be super, super thin, you can do that. Boom. Now we have our setup. There is another thing I just remembered. We can adjust the density of the grid. So right here, the vertices, if we want these both to come from the same value, we can just do like a simple math, and we can just say multiply by 1, and we can multiply both of these by 1, right? Right now, that means there's only going to be one streamline, but if we have 10, we'll basically have 10 by 10, just like that. So then in order to target that, we'll plug in our group input to the top value, and then we'll just name it right here. Scroll down. We'll name it grid resolution. Perfect. So now you can kind of see on the right-hand side. I'm trying to remember. Someone told me. Oh, there we go. That's it. I was going to say someone told me how to zoom in. There we go. So when you zoom in, you can now adjust the grid resolution. And if you want, you can kind of play this back in real time. We had 10 before. Let's do 30. Oh, Lord. Now that's a lot. It's going pretty slow. It's running pretty slow, but it looks wild. Let's adjust the radius a little bit. Wild. It's running so slow. It won't even cache the result. Hey, quick question. Is it possible to end them after a certain length and new ones spawn? Yes, it is actually. Let me show you. But also let me knock down this resolution to like 5 by 5 real quick. Okay, so let's say you want to end them at a certain resolution. What you have to do, because I remember this from a previous tutorial, also one of my previous tutorials, you have to add a delete geometry node right here in the wow, why is that not updating? It should be not playing at all because nothing should be updated. Hold on. Custom range. That's weird. It should not, nothing should be playing right now because it should be deleting all the geometry. Anyway, all you have to do is check if the position is, you have to compare it. And you have to say, is this position greater than, what would this direction be? Let me just check if this goes gy. That's positive y direction. So if it's greater than, I don't know, 1 on the, is this x, y, z? Yeah, 1. If it's greater than 1, delete it. Did that work? If it's greater than 0.2. Why is this not updating? Apologies, everyone. Something weird is happening with our simulation. Oh, we want it to be packed. No, we want it to be disk. Element-wise. It should be deleting the points that are in the positive. Oh, I did the positive x. Haha. Let's try that. Still not working. Anyway, that's how you would do it. You would say, is their position greater than a certain amount? If so, delete them. But why the heck isn't it working, guys? Chat, what's going on? Let's get rid of the custom range. What's up with that? What a vector. Hold on. Oh, hold on. No, not image info. Oh my God. I swear, this image info node is out to get me. Get out of here. I want separate. No. Let me ask you guys a question. This is so frustrating. Why is it that every time I type in separate, the image info node pops up? What does SEPE have to do with image info? I want to separate the XYZ, you son of a gun. I want the Y float. I want the Y to be greater than 0.1, 0.2. What? Hold on. Oh, maybe I have to use the stored named attribute. Hold on. Named attribute of... No, not the original position, because now we're not keeping track of the original position. It's the current position. And I am going to lose my mind. He said that's weird. I know, that is weird. Why isn't it? Usually down here, guys, you would see the lines appear like it would be every time I make an update, these lines should appear. And it's not happening. Started making fighting animations. That sounds cool. Wow, this one question is now going to drive me up a wall. Let's see if that works. Did that work? I did say Y, right? It's the Y direction. Y is this way. X is that way. Z is that way. So why is this not working? If it's greater than Y, I guess technically it's a vector, but it's really not, because it's right now it's just a float. Greater than 0.2. Let me just try negative 0.2. No. Let me try 1. 0.2. Delete it if it's greater than 0.2. And you're double checking. Oh. I think I know why. Maybe it's because this is not set to instance. That was it. It's because they're instances, they're not points. And I was about to lose my mind over that. All right, so now, there we go. We got it to work. All right, I deserve a coffee break for that. Sometimes it's the stupidest, simplest little thing, but that worked, because the reason it wasn't working is because our delete geometry node was not set to instances. And remember, if we go back, we instanced on points. We instance points, yes, but the points that we instanced onto the points are still instances because we didn't realize them yet until, well, actually, really, we didn't realize them at all. In fact, well, technically we did right here. We said instances to point. Why did I instance onto points with points? Why did I do that? Only me. I'm the only person that would ever do that. And I think I just said instances and points way too many times in one sentence. But the reason it didn't work, even though they're points, they're still instances of those points. Now that is like, it's like Inception or something like that. Anyway, it works, and that's how you delete. Like, if you decide, you know what, I'm done with these, excuse me, you can delete them. But right now, I don't want to delete them. I want the whole strand. Holy mackerel, guys. Holy mackerel. All right. Did that make sense, or am I actually going crazy here? Don't answer that. All right. Is there anything else you guys want to see covered? What do we got? 34 people watching. Oh boy. 34 people who are like, this guy knows nothing about Blender. That one was gonna drive me crazy. I was gonna lose sleep over that one. Like, you guys ever do? I mean, maybe this is just my personality, but when I can't solve a problem, instead of like being strategic about it, I just get really frustrated. And I'm like, what am I doing wrong? I kind of blame myself a little bit, but eventually when I get it, I'm like, why did I not think of that the first time? You just don't always see. Sometimes the problem's right in front of your face and you just don't see it. This could probably be a little bit more organized, like all this stuff right here is all for the gizmos. So let's do that. That happens to everyone. Apparently it does. Okay. All right, so we have our effector geometry, we have all of our physics, our initializers, our bounding box. Man, we got a lot going on here. Okay. This is why I like to put things in frames. Imagine if these weren't in frames right now, how much more this like would not make sense. Okay, good. Also, guys, as much as I thought we were going to use these like timing things, I'm going to go ahead and turn them off because, well, to be quite frank, they're getting in the way of the labels. So, yeah. Awesome. Looks good. Also, I don't know if you guys know this, there's a snapping tool right here. If you click that, everything will snap to the grid. But what's weird is I never found, let me correct me if I'm wrong, I never found a way to actually make them snap like, oh wait, of course now it works all on the live stream. But every time I used to try to like line up the tops, they like wouldn't line up. But actually it's actually working nicely right now. Anyway, maybe you have to zoom in a lot like I just did. That's like a lot nicer. Now I can go in here and I can like, but can I like fine tune this? Like there's no in between here. I wish the grid was slightly smaller. But now I can come in here and be like, you know what? These two. So like, why can't I? Oh, there we go. Ooh, that's much nicer, right, guys? Isn't that nice being able to like line everything up? I had them pretty decently lined up, but now you can like really like line things up. Like, let's see if that's lined up to that. Oh, perfect. Right? And get this guy. Oh, nice. Whoo! We should just do a whole live stream where we just align a bunch of nodes. Like they don't even really do anything. We're just lining them up like really nice. My PC specs, I have a GeForce 3070 Ti, RTX. Trying to think. Oh, Intel i9. I think I have like an Asus motherboard. I don't even remember like the exact one. I went to the Micro Center to buy all my PC parts, and then I built my PC like a couple years. Well, actually, it was like 3 years ago. Took me all forever to build the thing, but it was fun because I learned a lot. I learned how to be patient. I had to be resourceful. I had to call. There was a bunch of people I called. I was texting people. They were like, leave me alone. I was like, help me build my computer. I didn't know what I was doing. And I probably couldn't do it again, to be honest with you guys. Like, if you asked me to rebuild this computer right now, I'm not sure that I could do it. Come on. There we go. Wow. Look how much cleaner that looks. Like, let's get this going here. This guy has to be down there, though. That's fine. Oof. Come on. Oh, perfect. Let's get this guy here. Oh. Whew. 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 We are node experts out here, ladies and gentlemen. Let's do a little bit of this. Actually, we're going to have that go like that. That's fine. Clean. That's fine. I don't really need that. It's not really that important. Oh my God. There's nothing like just like some solid alignment on nodes. Am I the only one? No, I can't be the only one. And I used to well, usually when I'm randomly doing stuff, like I don't really put too much care into it. But right now I kind of care because, well, one, I'm live streaming, so I don't want to look bad. But two, I don't know. There is like kind of like a calming zen to it, like trying to organize. Like after all that hard work and like experimentation, now it's time to just like organize everything. Get all your thoughts in order here. Perfect. That looks solid. Look at that. Look at that little row we just set up there. It's fine. What else are we missing here? I wish this could be a little cleaner. This one's kind of annoying because, well, actually, this should probably be removed anyway. That's fine. I feel like that looks pretty good. Line that up. Came over. The way you store the original position and subtract it from each frame creates a bug that prevents the point from going beyond a certain value on the y-axis. Store position data in the simulation node. Ah, okay, let's try it. So you're saying right here, when I'm storing the position, I should just be storing it here. Remember though, are you talking about the position or the curve placement? Because this position, we still need everything to snap back into place. I can try it. Well, I didn't know. I might have to try that. Will that work? Talking about this, right? But remember, the original position will update every single frame, correct? Correct me if I'm wrong, but I'm pretty sure it will. But we'll try it. Now the question is, do we try it before the join geometry or right here? Stored named attribute. This is before. I feel like we should try it there. Position. And then we called it a vector instance, right? Still an instance. Let's try original position 2, and let's just see if we can. Let's just rename it here. That way we can keep the other one. You know what I'm saying? Oh, did that work? Hold up. This guy might be on to something here. Let me also, well, now I gotta see if, is this still reconverging though? The only problem is I don't think it's reconverging, but let's try something. Yeah, that is the only thing, is that the whole point of this code is that it has to snap back to the original position. Do you guys remember the old live stream? Just let me show you something. This is why I love this, but I love the concept of like what you're talking about, but I do want to show you guys. This project file is named I'm Going Insane. If that isn't me. All right, where is it? I think it's called Particle Push. Hello, brother. Hey, how you doing? Welcome, my friend. Welcome. Where's the particle pusher? Okay, I have to re-download it. Oh, here it is. Here it is. Is this it? Yeah, this is it. All right, so hold on. I don't want it to idle, actually. Set position. And I want all 3. Yo, someone broke this. It's okay, we'll re-download it. I'm going to my Gumroad page real quick, guys. You can admire my background real quick. My background is actually from a separate tutorial on my actual channel. I'm re-downloading something real quick, guys. There it is. Okay. So this one's fun. So this is from our old one. This, by the way, this is on a separate tutorial. I'm not going to cover this whole thing. But this right here, the reason this works is because you're storing the original position. So like, I'll just use the annotation tool real quick, even though I rarely use this. So like right now, there's an original position here. There's an original position here, 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 here. Every time the sphere gets close, these go out, away from the sphere, recalculated by the normal of the sphere. But then they have to snap back to their original positions, which are stored as like, almost like as an index. Really, it's just an XYZ. So like pretend this is like XYZ, like 1, 0, 0, whatever. 2, 0, 0. I'm just making an example. 3, 0, 0, 4, 5. They all have to snap back to their original positions. That's why you can't update it in the simulation zone, because if you do that, then their new original position will be here now and not over here where it once was. Does that kind of make sense? Or am I going crazy? I'm not going crazy. You're going crazy. All right, let's erase all this. Let's go back here. This one's fun though, because you can see, right? Like watch. You push them out of the way, they move right back to where they were before. See that? That's a really good example right there. Let's just take a look. Let's take a look at that, right? You move them, they move back. You move them, they move back. Eventually, what's cool is they kind of hover and they start like going around the sphere. Like you can see, like if we look here, they're all around this sphere here, which is really, really pretty cool actually. It's a cool little effect. All they are is little either points or icospheres. I think they're like dumbed down icospheres or something. How cool is that though? So fun. You need to change also some vector calculation also. You need to store pre-position and add them up each frame. Usually you should store velocity and you should normalize it. That's not a bad idea either. You know who did that really well? You know who's really good at this stuff? And this is where I learned a lot of this stuff from is Default Cube. He just like, I don't know. I wonder where he learned it, because I find it kind of hard to believe that you can just like come up with that on your own. But then again, people are super creative, so I have no idea. Although, not to brag, but this tutorial originally was just a bunch of nodes that I turned into this. Like it wasn't originally made for this specifically. It was actually made for something entirely different. And then if you just reformat a few nodes, you can kind of like get creative and have fun with it. Like for example, the logo, like you can make a logo particle effect with this. The original person that was asking about this in the forum may or may not have originally intended to use it like this. But man, is this fun. I like watching them float all around. So cool. So awesome. I feel like there's so much you could do with this. Like I feel like I barely scraped the surface of like what's actually possible here. Like you could potentially make like a fluid simulation with this. I don't know. It reminds me of like how a fluid might react. I don't know. I love this stuff. I don't know about you guys. But I don't know how to pronounce your name, but that is a great comment about the velocity, and it's definitely something to like consider. Don't think that I'm discrediting your comment. I just don't feel like adding all those nodes right now at the current moment. This is mesmerizing, honest to God. Here's what's really cool about this. You can do this in 3D. Like you can, or not, this is already 3D. What I mean is if you don't want this to be just a grid, right? Like right now it's just a grid. You can actually take this, you could make this a cube, and you could do mesh to volume, and then you could distribute a bunch of points in the volume. Distribute points in volume, and then you could instance onto those points. Do a density of 10. Where is our density? There it is. Okay, there it is. Okay, so let's do like 3 by 3 by 3. There we go. So now we have this kind of like point cloud, if you will. So everybody see that? And then you could see this is like something that I bet you might not have even considered. But now you have like this almost fluid-like thing, right? In fact, if you really wanted to, why not? Because we have a second. Let's go over here to the end, and let's do points to mesh. Now let's do, is it points to volume? Yeah, it's points to volume. And then hold on. Volume to mesh. Uh-oh. We may be going down here. Oh, first super on a live stream. That's awesome. It's my first class with you. That's awesome. Thank you so much for being here. Let's try a lower voxel amount. There we go. Now we can kind of... All right, so... Whoa. So here's what's cool. If I can make this work. Why can't I not... Wait a second. There's a way to do this, and I don't remember how to do it. Oh. That's it. That's it. Oh, no. Don't do this. Don't do this. Blender might be crashing. I hope you got... Did you get here early? Grandima J. Did I say your name correctly? Also, welcome. If you did just get here, welcome. Hopefully you didn't miss too much. Blender's about to crash on us here. I am going to end it. I'm sorry, guys. I got to end it. It's going to crash. It's going to mess up my whole computer if I don't end it. I'm sorry. Okay. All right, we're going to go back now. Are you actually joking me right now? There we go. Blender is... I love Blender, but sometimes it just doesn't want to do what I want it to do. Whew! You guys want to see a cool trick? Check this out. I bet you didn't know you could do this. Maybe you probably did. Did you know you can do something called a bounce spline? Let's see if I remember how to do it. You go to add curve, and then you go to knots, and you go to bounce spline. And what bounce spline does, pop open this. Wait. Well, I already confirmed it, but we'll do it again. So bounce spline basically takes an object and it will bounce a bunch of splines inside, and it'll make like a ball of yarn, basically, which is pretty cool. And then you can go over here and you can like take your geometry and you could extrude it, or you could use a round extrusion and you can make something that looks kind of like yarn. How cool is that? Now the only thing is once you do that, you now have curves, which isn't cool. Which is cool though. I'm so happy to learn with several tutorials. Yeah, thank you so much. Brother, there wasn't much money. That's all right. That's all right. It doesn't matter. You guys, I just appreciate you guys watching. It's not about the money for me. It really isn't. It's just about having fun, sharing knowledge and having fun. Seriously. Let's try something cool. Let's try Suzanne. Sorry, monkey. Let's do the same thing. Remember, guys, just go up here to add curve. I know you can't really see this. Knots, and then bounce spline. Now, look, there's this little option right here. You can decide how many bounces it has. You can also decide the angular noise, whatever the heck that is. Extra, I don't know what that is. Random seed, you can just change the seed. Resolution, you can raise that or lower that. Let's see what else there is. I feel like that's it. Boom. Now you have like sort of this Suzanne type of shape over here. How cool is that? Pretty easy. And then you can like set up some really cool lighting and make this thing look really cool. Suzanne the monkey. Very cool. Maybe that's a little bit too much. There we go. How awesome is that, guys? I don't know. I find this stuff pretty awesome. And then you can go in here, you can make a new material, make it whatever you want. And boom, you have yourself a threaded monkey. What else could we make? What else, guys? It's about 5 o'clock. We've been streaming for a little over an hour. We've been doing good. Does anybody have any questions? Anything they want to learn? Or just, do you want me to just keep doing random crap? Because I can do that too. Let me see if there's any other fun projects we can take a look at. Oh, this was the car generator. That was a fun one. This was liquid glass. That was also a fun one. Brother, I started a month ago. Is there a fast way to learn? I would say the fastest way to learn is literally by going to cgcookie.com and signing up. But also, if you want to, alternatively, you can go on YouTube and kind of check out a few of the big guys on YouTube. But I think it's better to have like a foundational course that you would take. You can pay for it, or you can try to find a free one. The paid courses on cgcookie are definitely worth it because the instructors are amazing, including myself. I'll call myself amazing if I need to. But I do think that we teach in a certain way that makes it super easy to understand and digest, even if you're a beginner. So I would highly suggest checking out cgcookie and either signing up or buying some of their courses to get started. I would highly suggest the core fundamentals. Those are through cgcookie. Oh, this one was cool. Looking back, like, this was a really cool project. Look how nice and organized these nodes are, too. How cool was this one? This one was a fun one. Again, cgcookie. Let me just go ahead and put that in the chat for you guys. That is the website you guys want to take a look at. Wow. How cool is that? So cool. You know what's something that I wanted to mess around with for a while is the Fibonacci sequence. Has anyone ever messed around with that? I'm just curious, like, because the Fibonacci sequence is like you take a segment and then you like split it in half, and then you split it in half again, and then you split it in half again, or et cetera, kind of something like that, sort of. I wonder if we could create something like that takes like a cube, and then it like shrinks it, pushes it over by that same amount, and then like shrinks it, pushes it over by that same amount, right? Something like that. Is that possible? I feel like it probably is possible. Maybe we can do that, and then we'll pause the live stream after that. But I think that could be really interesting. Which language is the course in? Should be English. There might be subtitles available. I'd have to look into that. All right, let me try something here. Let's go ahead and save that. I am just curious now. Let's go to geometry nodes. Let's add a new geometry node setup. Simulation. I want to take a cube. Okay. I want to scale the element 1.1 each time. So if we press play, it'll scale it, right? But maybe we only want to scale it on the Y. Let's go to split view down here. And let's do 30 frames. It's weird. Why is that? That's not how I wanted to do that. I only want to scale it on the Y by 1.1. So why? What? Let me try it with a grid. Maybe it'll work with the grid. No, why is it expanding multiple ways? Oh, single axis. Ha! Okay, my fault, guys. All right, so we want to make it single axis. Okay, so far we have the expansion. That's great. Which language is the course in? Yep, it's in English. And then where am I from? I am from the United States, my friend. But I won't get any more specific than that. All right, so we have it scaling out. Now, how much do we want to scale it? Where's the Fibonacci sequence? Fibonacci sequence. I just want to see something. I'm thinking probably way too hard about this. Just hold on. 21, 13. So the sequence of numbers is 0 to 1, 1 to 1 to 2. Oh, no, 0, 1. Shouldn't it be 0, 1, and then 2? Where's the sequence of numbers? 1, 2, yeah. 1, 2, 3, 5, 8, 13. So you're adding the last number onto the new number. Is this achievable? It certainly is. Why can't my brain wrap around this right now? Okay, hold on. I have an idea. I want to add 0.1. Okay. Oopsies. Okay, so we start at 1, 1, 1. We add 0.1 to the y each time. I'm going to call this Fibonacci. What are we going to do with this when we're done? Guys, I don't know. We're going to find out. Will you be my friend? Yes, I will be your friend. All right, so it scales up each time. So how about each time it scales up, we also set the position? Or what if we were to duplicate it? Hold on, let me think. If I want to split it, how would I split it? Cut it in half. Let me think about this. Because right now we're just scaling it, but I want to see like a split. So hold on. Oops, set. I just want to set the position. No. Oh, crap. No. All right, how about this? Split edges. It's kind of working. Hold on, split. I want to split. No, I want to extrude the mesh. I just want the top selection. Oh my god. Oh my god. Oh, you just add previous number. I know. Guys, something crazy just happened. I don't know what just happened. We're going to go back to this. Okay, I liked this better. All right, you just add the previous number. 1 plus 1 equals 2. 2 plus 1 equals 3. 3 plus 2 equals 5. Yep, I got you. Hold on, I'm trying to think of how to like split this up. Wait a second. You rejoin the grid. If you rejoin the grid, sometimes I like wonder why I'm trying to do what I'm trying to do. Join the geometry. Set the position. How would I separate? How would I how would I separate it though? Hold on. Take the grid, join it, but I want it to be like separated. Brother, I'm from India. It's 2 in the night and 45 minutes are on your side. It's 5:16 p.m. over here, buddy. All right, how long have we been streaming for, ladies and gentlemen? We have been streaming for 1 hour and 28 minutes. But we do have a really cool simulation to show for it. So I am very happy about that. All right, where was I going with this, guys? I was going to add something each time. I don't want to set the position anymore. Wait a second. We're scaling it, but what if we extrude it instead? Oopsies. And that is how you almost crash Blender immediately. What? Everybody seeing that? What the heck? Bro. Oh my god. Like, what? Oh, you know what I need to do? I need to specify the index. I need to say compare. And I would need to do integer is equal to 1. What? What is happening here? So, I mean, I understand what's happening here. I kind of like understand what's happening here. I guess my question is, why is it like rotating like that? Like, what would make it? Is it the offset? Let's try 0.2. No, it's not the offset. That's just how much it's extended by, or in other words, how much it's extruded by. But why? Like, let me just, I gotta try this now. I'm just curious. Oh. I don't know. It's kind of cool. I don't know, like, what we're looking at here. What? Like, what in the world? See how crazy we can make this. That's kind of cool. Oh. Who was asking the other day? They were like, can you make a geometric, like, abstract geometric creation? There you go. There's your abstract geometric creation. Thank you. Thank you for saying that, Mr. Camera. Very cool, right? I don't know what's happening here, but it's interesting. There's your easy bike spokes. There's a bike spoke generator. You're welcome. Thank me later. Oh, you know what I was making recently? We'll show you guys real quick. I'm just not gonna save this because I'm gonna show you. So we're gonna add a cube, and I'm just gonna show you. I was making a coffee cup generator. Hold on. This is pretty cool. So you take a cylinder, right? And then you say, I would like to delete the geometry, but I actually only want to delete the top, or I'm sorry. What did I say? I guess the side. Wait, what the heck? I just want to delete the face, the top face. There we go. So I want to delete the top face. I want to extrude this so I can have like a thickness, right? And then I just want to go ahead and rejoin it with the original geometry of the cylinder, so we have the inner wall. Well, I'm sorry, not that part. I want this part. Okay, and then I want to go ahead and merge by distance, and I want to do that right here. Perfect. So we merged by distance, and now this is nice and smooth. And then what's really cool is now I can go ahead and I can extrude again. But this time I can just decide which part of this I want to extrude for my handle. So I'll just do index, and then I'll just do compare. I'll say, is it equal to whatever I want? And I'll just shuffle through until I find one that I like. Oh, and also it needs to be a face, or face, that's fine. Actually, wait a second. Where's my other mesh? There, that works. Okay, give that a quick save as coffee cup generator. A unique sword? Boy. All right, so here's going to be our, what do you call it? This is going to be our handle here. You're going to love this, guys. Hold on. This is going to, you're going to crack up at how crazy this is, though. Subdivide mesh, right? Level 1. Now, look, now we have 4 pieces here. Hold on. I actually only want to subdivision surface. Hold on. I actually do want to subdivide this, but before I do that, I want to extrude another part of this mesh. I only want to extrude this part, but I want to extrude a very specific part of this. And then I'm going to create, what am I doing? Hold on. No, I want to delete this. I want to select part of this. I need to see it in wireframe mode. I need to split this edge. Hold on. That didn't work. I need to subdivide it. But not subdivision surface. It just needs to be regular subdivide. Okay. Perfect. 1, 2, 3. Okay, that works. And then what I'm going to do is I am going to extrude the mesh. But I only want to extrude an index, a specific index here. Look at that. So I can also do a Boolean here. Now, Boolean math. You guys are going to crack up here. This is going to be the most ridiculous thing you've ever seen. So I want 35. I also want 36. Hold on. I want equal to, and I want or. Yeah, look. So now look at this. I can decide which two that I want to extrude from. How crazy is that? So if I want to be like boom, 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 boom. Which one is it? Is it that one? I guess that could work. Although really, in reality, I want this part to be, I really only want 2 parts extruded off this for the cup. He said, please, 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 please. A unique sword. In the next live stream, I promise I will. There we go. All right, that works. 33 and 35. So now look, we can take that section and extrude it, and then we can actually do the same thing again. Hold on. I am going to copy this, and we're going to do 2 more, but we have to find which ones they are. So we have to do 1, 2, 3, 4, 5. Hold on. 2, 3, 4, 5, 6. 36 and. That's weird. How come I didn't get it that time? Which freaking index is this thing? What? You guys seeing this? Oh, wait, here it is. Oh, it's 47. Okay, so I know this looks crazy, but this is actually, like, this might actually work. All right, so we have part of our coffee cup here, and then now we just have to take those things, extrude them again, but this time we need to say, I would like you to extrude only a very specific selection. And we just have to find the selection that would be like that. Yep, like that, but it would need to extrude it in a very specific way. So hold on. Oh, I probably would also need to subdivide again. So just subdivide again. Just level 1, that's fine. Shuffle through these, see which one it might be. Nope, I missed it. You guys get the idea, though. You know what's funny? This is like the most procedural thing I could possibly think of, but it's really hard to do because you have to know exactly what index does what. And then at the very end, you can add the subdivision surface, but right now I don't feel like going crazy with this. I'll tell you what, it's pretty funny to think that you could model like a procedural coffee cup like this, but I would actually drive myself crazy, absolutely crazy trying to do this. All right, I will be totally honest with you guys. I just wanted to get through the aerodynamic simulation. So if you have any other questions, drop them down real quick and I'll answer them. But other than that, we're pretty much done for the day, guys. Maybe I'll hop back on tomorrow and see if we can come up with another live stream topic. But other than that, I had a lot of fun today, guys. I hope you did too. And I will talk to you guys probably in the next tutorial or the next live stream. Any other questions, drop them down below. We'll leave open chat for like a minute or two, and then we'll be done. We'll be finished up there. Don't forget, check out cgcookie.com/core. That is cgcookie.com. cgcookie.com/p/core. Do you know how to make PS1 graphics shader? Let me just look that up. I don't know how you would do that. I'm not exactly sure. Like a pixelated kind of shader. Probably just with a Voronoi texture or something simple like that. That's probably what I would do at least, yeah. Just an idea. Any other additional questions for me, guys, before we head off here? Thank you guys again for joining. Like, I really, really appreciate it. Any other additional questions for me? Yeah, PS1 graphics, I'd have to like look into how to do that. But quick question for you guys, like before we head off here, do you guys enjoy, like, what do you enjoy more, like talking about Blender, the actual interface and like interacting with Blender and learning the tutorials, or do you like to just chat? Because like we can also have a few, like I mean, the Node Dojo, that's kind of like an open chat for us, but do you guys prefer that over like just a tutorial or what? Also, I did not realize I could like do this in real time, but I can adjust this setup here in real time. I'm just curious though, because like we can also just have like a live chat. Like I could put the live chat here up on the screen and we could like talk and have a chat, or we could also just do Blender in general and we could just talk about Blender. I'm just curious what you guys think and what you prefer. I know I actually have another computer set up here in the background. That's my gaming computer. I have my my 3D printer and my regular printer. And then I have like a whole toolbox area over here where I have like all my inventions, fun things like that. Yeah, it's a pretty good room. This is like my office space. This is where mainly where I do Blender streaming, tutorials, like client work, stuff like that, and just like hang out and blend all day. As you can see, Blender. Got this from Beacon. Anything you do in Blender is pretty helpful for us, at least for me. That's awesome. I'm happy to hear that. I do want it, like I want it to be helpful for you guys. I want you to learn. And one of the things I want to encourage you guys to do a lot is just to like experiment, try new things. Don't be afraid to like mess up, you know? In fact, I encourage you to mess up because that's how you're going to learn quicker, especially in geometry nodes, because there's like no one size fits all. Geometry nodes is so powerful too. It's so powerful. This is what you get when you're a teacher and you have the summer off. You get to teach more in the summer, but I love it because I can do it in the comfort of my own home, right? And I can kind of just live stream without having to like there's no strings attached. It's just fun, you know. It doesn't have to be like, it can be educational, but it can also be relaxed. Whereas in the real classroom, that is where it gets a little crazy and the kids they're out of hand. Brother, type the video in a different language and upload it. This video right here, or are you talking about the courses? That would be something that you might have to contact CG Cookie about directly, but that could be an option. Yeah, that could be something that you could explore. I have a feeling they might support other languages. What is the native language that you speak, if not English? Definitely something I can reach out to them about. I will type a note. Let me hold on. Let me just type something out real quick so I can make sure I can reach out to them about that. What language were you requesting, so I can just kind of at least bring it to their attention? And you're talking about for the cgcookie core course, right? What was the language you're suggesting? Let me know so I can mention it to them, because I don't want anyone to be like left out of like the educational experience. Oh, you know what's really cool, guys? I have some. You probably can't see them. They're like right back there, but there's some blender pens right there. They're little blender pens. They're really cool. I got them from the conference. A lot of fun. All right, any last minute thoughts before we hop off here? Did anyone notice this fun little GIF here? How fun is that? I found that online. Hindi? Okay. I will definitely mention it to them. Thank you for letting me know. No guarantees, but I will try my best. Let's see. Oh my gosh, I forgot about all this. Oh, this one was cool. Maybe I'll cover this next time. Did I not cover this already? So this is not geometry nodes. Hold on. So this isn't geometry nodes, but this is something I did a long time ago. Man, how long ago was this? Probably like maybe a couple months ago. Just messing around with like particle simulations, and yeah, this was a cool one. So basically you set up like a particle simulation with thousands or millions of points, and you kind of like throw it through a turbulence force field, and you get this really, really interesting effect. So cool. I forgot how cool this one. I have faith in you. Thank you, man. I appreciate that. Really appreciate that. I'll ask them. No Hindi language. Yeah, I will ask them. I promise. Yeah, this one was cool. Maybe we will do this one next time. Maybe this will be the next topic. I'll pitch it to them and see what they think. They usually sometimes I'll do just like a free stream and I'll just stream whatever, but it is nice to have a planned topic in advance. Like this one, I could see this being a really, really cool thumbnail too. And the lighting in this, like, yeah, we could definitely cover something like this. Any tips on making animation render faster? Oh man, that is a loaded question. It's a loaded question because there's so much I would need to know about your project to know why it's not rendering fast. Obviously, lower samples, smaller size of your image, things like that. Turning down your light path settings, less compositing. Your materials are gonna increase your render time. Cycles versus Eevee, motion blur versus no motion blur, compositing versus no compositing, procedural elements versus non-procedural elements, baked data versus non-baked data, persistent data. What else? Oh, like how many light sources you have, like the types of materials you're using is pretty like important, because if you have glass, like in here I have glass right here, like that will take a lot longer to render than anything else really will. But these particles are easy because I think they're just like a diffuse BSDF with maybe some subsurface scattering. I'm pretty sure that's all I did there on that one. This one was cool though. Brother, show me one of your projects which you had trouble making. A project that I had trouble making? Okay. Oh, actually, project that I had trouble making was the one we went over today, which was the fluid simulation, or sorry, the aerodynamic simulation. That one was, I had a lot of trouble making that. I also had a lot of trouble making the blueprint shader. We've talked about that before. Let me see if I can find one. This one was difficult here. This one was difficult because the physics of this were really tough to get like and look like half decent, and plus the materials and the shading and all that stuff. Yeah, I would say this one was up there. There was a lot of like little things that I had to get just right. Arrow type of animation. What do you mean? Are you just asking? Are you saying that's what you want to see next? This one was fun. I could watch this one all day. It's actually quite simple to set up too. Well, looking back it was, but now I probably don't even remember how to do it. Just kidding, I probably do. But it's been a minute. Oh my gosh, look at this. This is a huge image. This was back before Superhive launched their new like website. I was making like renders for them. Look at the detail on this bad boy. This is just hair. This is a hair system. This isn't even like geometry nodes or anything like that. But tell you what, looked good. Looked very good. I do love looking at like old projects. That was a fun one. A little glass dispersion action there. Oh yeah, I remember this one. So this one was like a bunch of coffee beans. And then there was this. This was like coffee beans colliding. So like imagine you have a logo and you take an imprint of the logo and then you basically combine a bunch of, actually I did a tutorial sort of like on this exact effect. Man, this was a fun one. You basically just are colliding a bunch of rigid bodies together with a force field is really all you're doing, but you're taking an object that's not really active and you're hiding it. Now it has a border so you can get this logo like created, but then you just collide all the objects together to get an effect like this, which is really fun. Maybe we'll cover something like this next time. We'll see what kind of topics, but for now guys, I'm gonna head off. I hope you had a great day. I'm just about wrapping this up, and I want to thank you guys for like participating in the chat and hanging out, checking out what we had to offer today for our live stream. And don't forget, you can sign up for the CG Cookie core courses, and you can learn a lot more than what you learned today. So have a great day, guys. I will see you in the next tutorial.